Welcome to the video lecture series on the theory of computation. This is Dr.K.N.Sivabalan, and in today's video lecture, we'll be learning about the pumping lemma for regular languages. So, as far as pumping lemma is concerned, we are going to apply this pumping lemma only in infinite languages. Okay. So, pumping lemma is meant for to be applied in infinite languages. So, what is the purpose of pumping lemma? We try to take up a regular language and then we will prove that that language is not regular. Okay, so that is the idea behind using pumping lemma. We take up just like the rule of contradiction. We take up a rule, we take up a language finally, and we will prove that that is not regular. So the theorem for this pumping lemma is, say for example, if you take up the language called as L with the pumping length called as P, then a string W will be generated, and that string W actually belongs to the language. And finally, we have to prove that the length of W is always greater than or equal to the pumping length called as P. And the string is actually bifurcated or segregated into three portions called as X, Y, Z. And now we have to follow three conditions. If any one condition is not actually satisfied, then we can say that the corresponding string does not belong to regular language. So for I greater than or equal to 0, that means I can span from 0 to any value, and I keep x and z as ideal one, and we are going to vary only y here. So y keeps on varying, and if we keep on varying y component, finally the summation of x, y and z should actually belong to the language. So that is condition number 1. And in condition number 2, the length of the components x and y should be less than or equal to pumping length. And the next one is, we can say that if y is actually greater than 0, normally if you take up y, if y is greater than 0, then that is also one condition. So if any out of these three conditions, if any one condition is not getting satisfied, then we can say that it is not called as a regular language. Now we will step into the problem. So we will prove that. I just change pen settings. I will change this pen settings here. So I will have some other color. Okay. So prove the language. Prove the language L is equal to a to the power of n and b to the power of n, where n greater than or equal to 0 or n greater than or equal to 1, okay, is not regular. Okay, so the first step, we have to take up this n value, and n value is called as the pumping length here. So we will take n value. So n is called as pumping length. So n is called as pumping length. Now I will take it up, a to the power of n, b to the power of n. Let us take that n is equal to 2. If n is equal to 2, then if I apply this n equal to 2 in the language pattern, then L equal to a to the power of 2 and b to the power of 2, so is equal to AA BB. Okay, and we will take this W AA BB as W. Okay, now we have taken the string called as W is equal to AA BB. Now what the step number says is actually the length of W. So the length of W is actually 4. Okay. So now the length of W is actually greater than pumping length. So what is the pumping length? The n is equal to 2 is called as pumping length. So is 4 is greater than 2. So condition is meted out. Now we will just split up this W into three portions. Okay. So W should be splitted as X, Y and Z. So we have W is AA BB. Okay. Now I'll take A as X, A as Y and Z as BB. Okay. So X is equal to A, y is equal to a and z equal to bb. I will try to apply this rule. What the rule number 1 states is for any value. So what is the rule number 1? For I greater than or equal to 0, if x of x and y of I z belongs to the language. Now we'll just apply this rule number 1. So x is a, okay, and y is again a. So now I will just take I equal to 2 now. I equal to 2, so a squared, because y to the power of I is a, I is 2 and z is bb, okay, belongs to the language. So when I try to abbreviate it, a double a here, bb, okay. So what is the language pattern? It should have equal number of a's and equal number of b's, but here I have 3 a's and 2 b's, which does not fit into the language, so I just cancel this, okay. So this is called, it does not fit into the language, it does not belong to the language, okay. Since what is the rule states, if either one condition fails, then the language is not regular, okay. So since AAA BBB does not belong to language, does not belong to language L, hence it is not regular, okay. So even if one condition fails, then we can say it is not regular. Now condition number 2, I said that length of x and y. So the length of x and y should be less than or equal to pumping length. So what is pumping length here? N is called as pumping length. Length of x is a, length of y is again a here, length is 2 and pumping length is actually 2 here. So 2 lesser than 2, so no issues as far as condition number 2 is concerned. Condition number 3, length of y should be greater than 0. So length of y greater than 0, so length y is actually a, length of a is greater than 0, okay. So now even if one condition fails, condition number 1 fails, hence we can prove that language L equal to a to the power of n and b to the power of n is not regular. So thanks for watching the video. Have a good day.